Hello everyone, this is Mr. Kozlowski and welcome to the lecture on atomic structure in the periodic table. Today I'll be talking about Learning Target 1, Part C. Today, specifically, what we're going to be talking about is what is an ion. And what you're going to have to be able to do is determine the ionic charge of specific atoms for this particular part of the learning target. So, what is an ion? An ion is basically this. It's an atom that has gained or lost electrons. It's a charged atom. And this results in an overall negative or positively charged particle, depending on what happens to the atom. Did it gain electrons or lose electrons? This will determine the overall charge of the atom. If an atom loses valence electrons, the overall charge is going to be a positive charge. Remember, electrons have a negative charge to its particle. So what happens is if you lose negative charge, you're going to be left with more protons than electrons in the nucleus of the atom. Therefore, you're going to have an overall positive charge. If an atom gains valence electrons, it's going to have an overall negative charge because now, again, negatively charged particles are being added to the atom. It's going to have more negative charge than the positive protons in the nucleus. It has an overall negative charge. So if we look here, we have an example of an ion. Fluorine on the left hand side, we have the atom form, the stable atom form of it, where the protons are going to equal the electrons, and there's going to be no overall charge on that atom. However, if we add an electron to fluorine, you're then going to have one more electron than a proton, one more negative particle than a positive particle. You're going to have a negative overall charge. So basically, that's what an ion is. Determining ionic charge is a skill that you're going to have to do. And basically, ionic charge is determined by how many valence electrons an atom has. It is an indicator of how many electrons an atom must gain or lose to get a full energy level electron. So understand that we talked about this rule of octet in the last lecture. Basically, that full number is 8. All right, so atoms want to have a full outer energy level with electrons all the time. They want to be what we call happy atoms and be stable. So 8 electrons are needed for most energy levels. The only exception to this rule is energy level number 1, which you only need 2 electrons to be full. Atoms that have a full energy level are said to be, again, stable. If they are not full, they are unstable atoms, or what we call a charged atom, and they are potentially, we call these ions. So how do I determine the ionic charge of a specific element or atom that's given to you? So for example, let's take magnesium. Magnesium is found in main group 2, and we talked about briefly what the main group was in the last lecture, but since magnesium has 2 valence electrons, it wants to lose those electrons. It's easier to lose 2 electrons than to gain 6 electrons to get to 8. So therefore, magnesium's ionic charge is going to be +2 because it wants to basically have a 2 plus positive charge to get rid of those valence electrons. Chlorine is the opposite because it's found in group 7. It has 7 valence electrons at its outermost energy level. So it needs 1 to be happy, 1 electron to be a happy atom or stable atom. Therefore, its ionic charge is -1, indicating that it needs 1 electron to be full. So that's basically the ionic charge. If an atom is closer to 8, it would rather gain electrons. If it is closer to the opposite end of the spectrum, where it's closer to 0 or 8 the other way, it will want to basically get rid of those electrons. So just kind of keep that in mind. And this is going to be something that you work on with ionic compounds later on in the unit as well. So again, here's the groups. So again, magnesium was found in group 2. It's closer to 8 the other way. It's going to get rid of its 2 electrons. And then again, over here, we had chlorine in group 7. It needs 1 electron to get to 8 and be happy. Group 8 is a special name. We call that the noble gases, and they're happy already. They don't want to gain or lose electrons. So ionic charge examples, here's some things that you're going to have to worry about. What I want you to do in your notes is just briefly take a guess, okay, or just calculate what the ionic charge for these atoms are. I know this might be a difficult concept, but once you get the hang of it, it's relatively easy, right? So we're going to be reviewing these in class once we get back, and we'll use this as a warm-up. So please review those and have those ready to go in your notes. The other thing is we have to name these ions. And naming is important when we get to writing compounds. So if you have a negative ion, you need to add a suffix IDE to the end of the name of the atom. If you have a positive ion, you're going to have to add the word ion to the atom's name. So for example, lithium is basically a +1. That's going to be a positive ion, so I'm going to name it lithium ion. Fluoride is a -1. That's going to be fluoride. That would be the name. So those are your two examples that you can use to help you out with this. So try to name the rest of those ions on your own. So again, to review, ions are charged particles resulting from an atom gaining or losing electrons. And when we talk about electrons, we are specifically referring to valence electrons, the outermost energy or outermost electrons in the outermost energy level. Ionic charge will determine how many electrons an atom needs to gain or has to lose to get full energy level. And then the ionic charge can be determined by looking at the main group or the column the element is located in. And then again, make sure that you use suffixes properly to name these ions. If it is a positive ion, again, you need to add the word ion to the end of the atom's name. If it is a negative ion, you need to add the suffix IDE to the end of the atom's name as well. So again, if you have any questions, please let me know. You're going to get a lot of practice in this unit with naming and trying to determine the ionic charge of these atoms. So let me know if you have any questions, and we'll see you guys in class.